Let's have a theorem. In a circle or in congruent circles, two minor arcs are congruent if and only if their corresponding central angles are congruent. So this is a shortcut for if and only if. So IFF for if and only if. So this means that hello everyone, welcome to FatMath TV. So in this video, you will learn the chords, arcs, and central angles of a circle and their relationships. So let us start. Sum of central angles. The sum of the measures of the central angles of a circle with no common interior points is 360 degrees. So like for example, this one, if you have the, we have here angle 1, angle 2, angle 3, and angle 4. These are central angles of the circle, and these four angles don't have common interior points. So the sum of the measures is 360 degrees because the whole circle is 360 degrees. So measure of angle 1 plus measure of angle 2 plus measure of angle 3 plus measure of angle 4 is 360 degrees. So if you're given with the measure of the others, you can obtain the last one by subtracting the sum of the others from 360 degrees. Arcs of a circle. So minor arc AB. So here's the minor arc AB. So when you say minor arc, it's smaller than a semicircle, and we use two letters to name a minor arc with this symbol here at the top. Okay, so this means it's arc AB. And then for a major arc, we use three letters. It's this one. Major arc CAB is from here, from C going to A, going to B. So around the circle. So that's major arc CAB. So as what you can see, it's bigger than a semicircle. And a semicircle is, we can use three letters, A, B, C. So from A through B to C. So that's a semicircle ABC. So this is how we name arcs of a circle. Degree measure of an arc. The degree measure of an arc is equal to the central angle that intercepts the arc. So like for example, in this case, the degree measure of arc AB is equal to the central angle AOB. So in this figure, we say that this angle AOB intercepts arc AB. So the measures are equal. And then the degree measure of a major arc is equal to 360 minus the measure of the minor arc with the same endpoints. For example, you're asked to find the given the measure of arc AB. How will you identify the measure of arc BCA or ACB? So you just subtract from 360 degrees. For example, this arc AB is 40 degrees. What is the measure of arc ACB? So it's simply 360 minus 40, that is 320 degrees. And the degree measure, of course, of a semicircle is 180 degrees because that is half of 360 because it's half of a circle. So a semicircle is 180 degrees. So measure of arc ABC in this illustration is 180 degrees. Congruent circles. What are congruent circles? Circles with congruent radii. So if the measures of the radius are the same, then the circles are said to be congruent. So circles with congruent radii. And congruent arcs are arcs of the same circle or of congruent circles with equal measures. So they can be arcs in one circle or of different circles but congruent circles. So congruent arcs are arcs with equal measures. Okay, let's have a theorem. In a circle or in congruent circles, two minor arcs are congruent if and only if their corresponding central angles are congruent. So this is a shortcut for if and only if. So IFF for if and only if. So this means that if angle AOB here, angle AOB, this is a central angle, and angle COD, they are, if they are congruent, so these angles are angles of the same circle. So if AOB is congruent to COD, then this arc, the intercepted arcs AB and CD are also congruent. But take note that this is an if and only if statement, so the converse is also true. That is, if these two arcs AB and CD are congruent, then angle AOB and angle COD are also congruent. So that is by this definition of if and only if. So two statements. If this premise, then this conclusion, and then if this one, then this one. Okay. Another theorem. In a circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. So in this illustration, if line segment AB or if chords AB and CD are congruent, then arc AB and arc CD are congruent. Equivalently, if we are given that these two chords AB, I mean these two arcs AB and CD are congruent, then the two chords AB and CD are congruent. Another, in a circle, if a diameter bisects a chord and an arc with the same endpoints, if and only if it is perpendicular to the chord. In a circle, a diameter bisects a chord and an arc with the same endpoints if and only if it is perpendicular to the chord. So in this illustration, we have here diameter AB. So it bisects the chord CD and arc CD. So, meaning to say, if you say it bisects, it divides it into two congruent parts. So, meaning to say, this diameter AB divides CD into CE and ED, which are congruent. Or, arc CD is being divided by diameter AB into arc AC and arc AD. So, arc AC is congruent to arc AD when we say that AB bisects arc CD. So if it bisects, then it is perpendicular to the chord, meaning to say if it divides the arc and the chord into two congruent parts, then this line segment AB is perpendicular to CD, meaning to say it forms right angles here. So angle AED is a right angle, also AEC, also CEO and OED. Also, the converse is if, wait, if AB is perpendicular to CD, then it bisects the two, the arc and the chord. So if diameter AB bisects chord CD and arc CD, then diameter AB is perpendicular to chord CD. And the other one is, if AB is perpendicular to chord CD, then AB bisects CD, chord CD, and arc CD. Okay, let us have the arc addition postulate. The measure of an arc formed by two adjacent arcs is the sum of the measures of the two arcs. So in this example here, we have the measure of arc CD from C through A going to D is equal to the measure of arc CA plus arc AD. So that's what the arc addition postulate says. Okay, let us have examples with those concepts that were given. Let us answer the following. In circle O, measure of angle BOC is 45 degrees. It's here, BOC. Measure of angle COD is 50 degrees. COD, 50 degrees. Angle COE is a right angle, meaning to say it's 90 degrees. COE. And AD is a diameter. Okay. Find the following. Measure of angle DOE. So DOE. So as what we can see here, COE is 90. So from here going here, it's 90 degrees. And this one is 50. So this one is 90 minus 50. That is 40 degrees. How about AOB? Where is AOB? AOB, this one. So we can use that this AD is diameter, meaning to say it's 180 degrees here. But this one is 50 and 45. So this is a total of 95. BOD is 95. So if that's 95 and the total is 180, so 180 minus 95. So 180 minus 95 will give you 85 degrees. So AOB is 85 degrees. So this one here is 85. This one here is 40. How about angle AOC? Where is AOC? AOC. So we have here 85 plus 45. That is 130 degrees. How about AOE? AOE. So we can have this AOD is 180 and this one is 40. So 180 minus 40 is this one. So 180 minus 40 is 140. 180 is a semicircle or a straight angle. And then you subtract 40 from that, 180, and you will get this AOE. 140 degrees. How about BOE? BOE. So as what you can see, it's just the sum of 45, 50, and 40. So that's 135 degrees. So BOE is just 45 plus 50 plus 40. Okay, how about the following arcs? Measure of arc BC. BC, so that's just equal to the central angle, so 45 degrees. How about CD? Also equal to 50, so that's also 50 degrees. How about AE? AE is just the same as AOE, so that is 140 degrees. We have solved that here in the angles. ADE. ADE. So that can be 360 minus AOE or AE. ADE is from here going here. But AE is already 140. So 140. So we can subtract 140 from 360. So the remaining will be 220. So 220 degrees is the ADE. How about EAC? EAC. EAC is this from here, from E through A, going to C. So that is also 360 minus 90 degrees because CE is 90. It's given. So this is 90. So you subtract 90 from 360, you will get 270 degrees. Another example. In circle O, OD is 12. This one, OD. CD is 5. CD is 5. And OH is square root of 105. Okay, find the following: OC, BD, AC, EH, and EG. Let's start with OC. So OC is the radius of the circle. So OC is the radius of the circle, and as what you can see here, angle D is right angle, meaning to say OB is perpendicular to AC, meaning to say AB and AC, arc AB and arc BC, are congruent, and AD and DC are also congruent. So this makes a right angle. So we can use the Pythagorean theorem. We know the two legs, 5 and 12, and we are asked for or we will solve for the hypotenuse. So OD squared plus CD squared is OC squared. So the sum of the squares of the two legs is equal to the square of the hypotenuse. So OD is 12 and CD is 5. So just substitute. And then 12 squared is 144. 5 squared is 25. 144 plus 25 is 169. Since that is the square of OC, to get OC, take the square root of both sides. You will get 13. So OC is 13. So this one is 13, meaning to say the radius of the circle is 13. So this is 13. And a circle is a set of all points equidistant from a fixed point called the center of the circle. So this is also a radius. So this is also 13. And we can use this to find EH and EG. But let's solve first BD. OB, as what you can see, OB is also a radius. So from O up to B, or going to B, that's 13 units. But OD is 12. So 13 minus 12 is 1. So BD is just 1 unit. How about AC? AC. Without solving for the 13, we can solve AC immediately because this AD is the same as CD. So AD is also 5. Okay, we are using here our theorem a while ago. So if this is 5 and this is 5, AC is 10. Okay, let us solve for EH. We will use the Pythagorean theorem again. So the sum of the squares of the two legs, we will use this triangle here. This is the hypotenuse, and these are the two legs. So one leg is unknown, that's EH. So we have OH squared plus EH squared equals OE squared. So OH is 100, square root of 105, EH is unknown, and OE is 13. So 100 square root of 105 squared is 105. Square of 13 is 169. So we can transfer 105 to the other side, and EH squared is 169 minus 105. That is 64. Taking the square root of both sides, EH is 8. So EH is 8. So this one here is 8. How about EG? EG is just twice of EH. Okay, so from the theorem, so that's 16. So if diameter or radius is perpendicular to a chord, then that radius or diameter bisects the chord and the arc. That's the theorem that we are using to solve this. And then since we have a perpendicular, we have two perpendicular segments here, we are using the Pythagorean theorem because triangles are formed by the radius and the other two line segments here. So the Pythagorean theorem states that the sum of the squares of the two legs is equal to the square of the hypotenuse. So those are the concepts that we used in solving these items. So I hope that you learned. Please continue to support this channel by liking, subscribing, and watching the videos. So that's it for now. I hope that you will enjoy the next videos that I'm going to upload. Bye!